Now that we've got component form, it's a very simple matter of finding what the dot product is. So if we go back to what the definition of the dot product is, we've got A dot B, and don't forget the dot product is also known as a scalar product because we get an answer of a scalar. And by definition, it was the absolute value or the magnitude of vector A times the magnitude of vector B cos of theta, where theta is the angle between the two vectors. So if you like, we've got A and vector B, and theta is the angle in between them. And this answer obviously is a scalar because we've got scalar, scalar and scalar. So we've got A dot B. But if we've got vector A now in component form, so it'll be A1I plus A2J plus A3K, and vector B is equal to B1I plus B2J plus B3K. And don't forget that any of these A1, they're all scalar quantities. All of those could be negative, so it applies for that as well. It can be shown, I'm not going to go into the proof, that A dot B, now that we've got component form, is simply A1, B1. You just multiply the I components, you multiply the J components. Now this also applies for 2 dimensions, so even if you don't have the K's, it would be just that if it was 2 dimensions, plus A3, B3. So that's a nice, easy way to be able to calculate the dot product or the scalar product. You just, now that you've got it in component form. So a couple of the properties of dot products. So properties. First property is that A dot B equals B dot A. We say that's a property that's called commutative. Commutative means we can do it in any order. So hopefully up here you can see that B1 A1, and here you'll have B2 A2 and B3 A3. They'll be the same as A1 B1 A2 B2 and A3 B3. So that's a property that holds true. 2, that if you've got A dotted with B plus C, that the dot product is what we call distributed over everything inside the bracket. So A scalar product B plus A scalar product C. Now because the A is distributed over everything inside the bracket, we call that the distributive law. Third property is if K is a scalar, so it's just a straight number, it's not a vector, then K A dot B is equal to, now in this case it's a bit different up here. The K is not distributed over A and B, it's only just this is this inside the brackets will end up being a scalar quantity, so it'll be just that times that, so it'll be just K A dotted with B. So what you can do is you can actually multiply that scalar quantity by vector A, and we've done that previously, and then do the dot product. Doesn't really matter, you can do the dot product first and then multiply your answer by K at the end and get the same answer. And the last property you should be aware of is that any vector dotted with itself will be just equal to the magnitude squared. Alright, so by definition of what we've got up here, A dotted with A will be A1, A1, and plus A2, A2, plus A3, A3, and that's A1 squared plus A2 squared plus A3 squared, which is the absolute value of A all squared. All right, so that gives us a little bit of an easier process for doing dot products. We've done it before when you can find the absolute value of A and B and then you know the angle in between, but if you don't know the angle in between and you've got it in component form, you just got to multiply the I's, the J's, the K's, add those up and you'll get an answer. All right,